Dear student, in the last class we have discussed about electric potential, and today we will discuss about uh, uh, electric circuit and Ohm's law. We have discussed about the passage provided to the flow of electric charge. This is called electric circuit, and when the circuit is turned on, the positive terminal, which is rich in potential or rich in positive charge of the battery, which is at high potential, pushes the positive charge into the bulb through connecting wire, and at the same time negative terminal of the battery, which is deficiency of charge of the battery, which is at low potential, pulls the positive charge from the bulb because of its polarity through the connecting wire, and again push at the other terminal of the bulb. And in this way, this cycle of pulling and pushing continue. And so bulb glows continuously. So while pulling and pushing, energy is required. So this energy is supplied by the battery in terms of chemical energy present in the electrolytes of the battery. When this chemical energy exhausted, the glow of bulb get stopped or get dim. So this act of pushing charge through the positive terminal at the same time withdrawing the same amount of charge through the negative terminal, this is known as the completion of the circuit. If one break the path in between the two terminal of the cell or battery, then pushing and pulling cannot be completed. So there we cannot have a continuous flow of electric charge. Although there will be electrical energy in the form of electric potential, but we can't have uh, kinetic energy in the electron, because kinetic energy of electron itself constitutes electric current. So in that case, if circuit is broken, then there might be electrical energy there, but it cannot be converted into electrical current. So for completion of the circuit or complete circuit, it is essential that the two action must accompany simultaneously, pushing the charge at one end of the conductor and a withdrawal of the charge at the other end of the conductor. And this can be done by an external agent, uh, which is called cell or battery. As circuit becomes complete, bulb starts glowing. Bulb will not glow if circuit is not complete or open. It means that we cannot make a bulb glow by connecting it only to high potential or to a low potential. It means if you connect the bulb only with a high potential, then uh, bulb will have only high potential and there is no way to flow the charge. So if we connect the other terminal of the bulb with low potential, then charge will flow from high potential to low potential. And this purpose is fulfilled by a device that is called electric cell or battery. So in order to have a continuous flow of electric current through the circuit or through the bulb, so that bulb can glow continuously, we must have created a potential difference. We must create a potential difference by connecting the conductor between high potential and low potential terminal of the battery to pass the current through it. So all these were the in brief. So now we move on the new topic, Ohm's law. As current starts flowing through the conductor,
सर एक बार फिर से बता
as current starts flowing through the conductor, अजय,
सर
हाँ जी,
सर एक बार फिर से बता दीजिए ना
इसको तो फिर YouTube पर जाएगा ही, वहां देख ही लेगी, ठीक है। तो ये सब मुझे लगता है ये प्रीवियस टॉपिक में पहले डिस्कस किया था, ठीक है, इसलिए डोंट वरी, और इसको YouTube पर फिर से देख सकते हैं, ठीक है। ओके, भाई जस्ट आज ही कुछ देर के बाद अपलोड कर दूंगा, ओके। Now, try to understand, we have to now learn about Ohm's law. So first of all, let us talk about, so far we have discussed about electric circuit. Electric circuit has been briefed in the previous class. So here, you know that electric circuit is a passage provided to the flow of electric charge in terms of conducting medium. And an electric circuit comprises a cell, battery, plug, key, electrical components, and connecting wires, etc. These are the essential components for electric circuit. Electric circuit is not a single unit. It is an integral part. It consists of so many essential components. When these components connected in sequence, then altogether forms electric circuits. It is often convenient to draw a schematic diagram in which different components of the electric circuit are represented by symbols conveniently used. So here we will learn about the symbol of various component of electric circuit that we would use to draw a schematic diagram for electric circuit. Conventional symbol used to represent some of the most commonly used electrical components or components of the circuit are given below. So just have look at a glance. So this is the electric circuit diagram for electric circuit, and this electric circuit consists of an active device which is called cell or battery that supply energy, and a switch connected in series, and a bulb that consumes electrical energy supplied by the battery. And this indicates the direction of flow of free electron in the conductor. This line indicates conducting wire. So electron always flow from positive part of the circuit to, from negative part of the circuit to positive part of the circuit. On the other hand, conventional current flow from positive part of the circuit to negative part of the circuit. And as this electron moves across the device which is connected in series with the circuit, the device works or consumes, absorbs electrical energy and transformed into another form of energy. As for here, example here, bulb. It is an electric bulb. So when electron moving through this bulb and then through this way, the kinetic energy of electron uh, get used by the bulb, because bulb filament has high resistance and this resistance opposes the flow of electron. Therefore, kinetic energy of electron get decreased while passing through the filament of the bulb, and hence loss in kinetic energy appears as a heat and light energy. So bulb starts. So we will discuss in deep in later. So this is a circuit diagram, and now various components of electric circuit that can be symbolically represented as. So cell can be represented. This is a cell, can be represented by two vertical lines. One is bigger lines and another is a smaller line, but they are parallel to each other. So bigger vertical line indicates a high potential, positive potential, and a smaller vertical line indicates low potential or negative potential. And there is a space between the two lines, and in between these two spaces there must be some chemical energy available in terms of electrolytes and etc. Next, battery. Battery is nothing but a combination of two or more cells. So two or more cells when connected in series, this makes up a battery. So look at how to connect series a cell. Positive terminal of the first cell is here, and negative terminal of the first cell is connected to the positive terminal of the second cell, and similarly negative terminal of the second cell is connected to the positive terminal of the third cell, and so on. So this is called series combination. In this case, if potential of this cell is 1.5, then this combination will have 3 times the potential that of this. That means 4.5 potential here. Next symbol is plug key or switch open. This is the symbol of switch open. So if this symbol is present in the circuit, this indicates that a circuit is open, not closed or broken. Now,
क्या हुआ?
and now,
एंड कर दी क्या? टाइम
now,
एंड हो गया होगा।
now plug
45
key, note of plug key or switch closed. This symbol indicates a closed circuit. And this point, this is the junction of the wire. A wire joint or junction can be denoted by this, in which two or more wires come in contact at a single point, electrical contact at a single point, that is called junction or joint. And now wires crossing without joining or without being in electrical contact. So this symbol indicates that the two wires cross over each other, but they are not in electrical contact with each other. This symbol indicates, this is the symbol of filaments, actually indicates to represent bulb, electric bulb. Actual figure of the bulb is this one, but only this is filament, so indicate a bulb. So in circuit, when this symbol is present there, it will indicate that there is a bulb connected in series with the circuit. And bulb is also a two-terminal device, so it can be connected in series and parallel. So a resistor of resistance R. A resistor is an electrical device which has inherent property of hindrances that opposes the flow of electric current through it. So this is the resistor, and resistance is its property. Symbolically, a resistor is denoted by this. Okay, indicates that when
सर
current.
रेसिस्टर नहीं समझे।
A resistor is an electrical device which has inherent property of opposing flow of electric charge when passes through it. Okay. A resistor is a device which has inherent property to oppose flow of electric current through it. Okay. Inherent property means materialistic property. A resistor is made up of certain kind of material. So whatever the materialistic property of that material would be, various material have various level of opposing flow of electric current. So various material have very different amount of resistance. So resistor is a device that tends to oppose or opposes flow of electric charge or electric current passing through it. Got it? Resistor. And resistance is property of resistor. Remember,
Yes.
resistance is property and resistor itself is a device. We can touch resistor. We can collect resistor. We can buy resistor, but we cannot see resistance, but we can see effect of resistance. So resistance is inherent property, hidden property in the resistor. Now, come to next point. Resistors could be of two types: a resistor of fixed resistance and resistor of variable resistance. A resistor of variable resistance is also known as rheostat. A rheostat is a resistor of variable resistance. We can vary the resistance. We can change the resistance as per desired. So variable resistors can be represented by this. Of this symbol. This symbol indicates rheostat, and this indicates the resistors of variable resistance. And now next symbol is ammeter. That is a measuring device which is used to measure electric current. And this ammeter is a two-terminal device. One terminal is connected at positive and one is denoted as negative. Therefore, while connecting the ammeter in the circuit, so positive terminal of ammeter is connected with the positive part of the circuit, and negative terminal of the ammeter is connected with the negative part of the circuit and connected in series. Next, voltmeter. Voltmeter is also a measuring device, and it is also a two-terminal device, and hence it has positive terminal and as well as negative terminal. So voltmeter, while connecting in the circuit, positive part of the positive terminal of the voltmeter connected in positive part of the circuit, and negative terminal of the voltmeter is connected to the negative part of the circuit. But remember, voltmeter always connected in parallel with the part of the circuit. Next, now we come to Ohm's law. Ohm's law, just to have a brief introduction about George Simon Ohm. Full name is George Simon Ohm, who, who was born on 16th March in 1789 and departed from this earth on 6th July 1854. And he was a German physicist and mathematician. George Simon Ohm was a German physicist and a mathematician. And he taught in a school as well. So as a school teacher, Ohm began his research with the new electrochemical cell. At that time, first time electrical cell was given by uh, Alessandro Volta, an Italian scientist. So because first time George Benjamin Franklin, when discovered about electric charge and trivial current or moment, for a moment current flows in the clouds. And during that period, most of the scientists started researching about the electric current and electric potential and so on. So, being a school teacher, George Simon Ohm, being a school teacher, started his research with the new electrochemical cell, and which is invented by Italian scientist Alessandro Volta. That's why SI unit of potential difference is given as volt. You see, this name and this word has been derived from the name of Alessandro Volta, because Alessandro Volta first time invented the cell. Now, using equipment of his own creation, George Simon Ohm created his own equipment for measuring effect of electric current through the various material or various conductors. So using equipment of his own creation, Ohms found, when he allowed to pass electric current through a conductor, he found that there is a direct proportionality between the potential difference, say potential difference we say voltage. There is a direct proportionality between the potential difference or voltage applied across the conductor and a resultant electric current passing through it. So basically, Ohm's concluded that there is a relation between electric current and potential difference across the conductor. In the previous section, we have learned that we can't have continuous flow of electric current through a conductor until and unless we create a potential difference across the terminal of the conductors. And now, as for the continuous flow of current, for the condition for the continuous flow of current, there must be a potential difference across the conductor, across the terminal of the conductor. That is, one terminal of the conductor must be kept at high electrical potential, another terminal of the conductor must be kept at low electrical potential. In that situation, electric current will start flowing. Now, George Simon Ohm came to know that when potential difference is applied across a conductor and current starts flowing through it. So current flowing through the conductor is directly proportional to potential difference applied across it, and vice versa. Even one can say that potential difference across the conductor is directly proportional to current flowing through this. Both statement is equivalent and equally true. Try to remember that current flowing through the conductor is directly proportional to potential difference. More is the potential difference applied across the conductor, more current will flow through it. And if you reverse the same thing, potential difference across the conductor is directly proportional to current flowing through it. More is the current flowing through it, more potential difference will be across the conductors. So this was the brief introduction about the George Simon Ohm. So now we came to know that George Simon Ohm gave a relationship between electric current and current and potential difference across the conductor. And in between this relation, a fundamental or basic properties of material get involved. That is called resistance. And so in case Ohm's law, resistance, electric potential, and electric current, all three physical quantities are uh, interrelated to each other and forms an equation and satisfy Ohm's law mathematically. So try to understand what is Ohm's law here. Explain. Ohm's law explains a relationship between voltage, that is potential difference, and sometimes we talk about voltage. Wherever voltage is there, there must be electric field present. So voltage is a scalar aspect of something, and electric field is a vector aspect of the same thing. We have told you that a charge can produce a surrounding around it that could be of two types. That could be realized in two different ways. One in vector term and one is a scalar term. So electric potential is a scalar and electric field is a vector. So when we talk about electric potential V, at the same time there must be present electric field, because V potential can only be created that if we produce at one point positive charge and at one point negative charge, then we say that between positive and negative potential difference exists. At the same time, I told you that electric field always direct from positive to negative. So at the same time, electric field also exists. So here, Ohm's law explains the relationship between voltage, that is potential difference, or electric field, or EMF. Later, I will discuss about EMF. Now, and current as well as a resistance. So there are three physical quantities: voltage, current, and resistance. Resistance is denoted by capital R, and resistance is the inherent property of matter and also depends on physical condition of the matter or conductor. Now, Ohm's law is so important that you would come to know that almost in various fields of life it is used here. It is used by electrician while making domestic circuit, and it is used by automotive technician. Ohm's law is also used by automotive technician and a stereo installer. In case of a stereo installer, their Ohm's law is used. So Ohm's law is so important, and in other various aspects of life and walks of life and various other purpose, Ohm's law can be used. So here just we have to be familiar with the Ohm's law and a little bit well-known applications. Now come to know, so far we have discussed about Ohm's law, and if someone asks you that what do you mean by Ohm's law, just recall that it is nothing but a relation between potential difference across the conductor and electric current flowing through the same conductor, and inherent property, say resistance of the conductor. This Ohm's law gives a relation between these three physical properties. Now, any law is there, we must learn about the statement of that. Then we apply mathematically. So here, Ohm's law statement, what do you mean by Ohm's law? Just you have to write that according to this law, or according to Ohm's law, potential difference across the conductor is directly proportional to current flowing through the conductor, provided temperature of the conductor kept constant. देख लो, मैं यहाँ जैसा लिखा हुआ है आप ये भी याद कर सकते हो, लेकिन मैंने क्या बताया वो भी याद रख सकते हो. According to Ohm's law, electric potential across the conductor, or electric potential difference across the conductor, is directly proportional to the current flowing through the conductor, provided temperature of the conductor kept constant. In other words, even you can define that electric current flowing through the conductor is directly proportional to the potential difference across the conductor, provided temperature of the conductor kept constant. Both the statement is 100% correct. Whatever you want to follow, you may do. So this is the statement of Ohm's law. Say you take a conductor of length L and you connect this conductor with a battery, single battery of 1.5 volt along with a bulb. You will see that when one single battery is connected across the conductor or across the terminal of the bulb will glow, but intensity of glow will be low. Now what you do? Now combine two battery together, 1.5 volt and 1.5 volt. Now we will have 3 volt potential difference across the terminal of the bulb. Now again bulb will glow, but intensity of glow will get increased twice. And when you combine 3 batteries together, again bulb will glow but with greater intensity. In this way, can you see that why intensity go on increasing as we increase the battery? Number of battery when connected across the bulb increases, the intensity of glowing bulb get increased, because as you increase the battery, potential difference across the terminal of the bulb increases, and so current across the bulb also increases. That is, amount of charge flowing per second also increases. That's why bulb glow brighter and brighter. This indicates that this satisfies Ohm's law. So mathematically, that was the statements of Ohm's law just earlier we have discussed. Now, mathematical aspect of Ohm's law we have to learn. Just suppose a conductor is there and a potential difference V applied across the conductor, across the terminal of the conductor. Say one of the terminal of the conductor is kept at positive potential, say V plus, and other is kept at negative potential, say V minus. So potential difference between the terminal of the conductor is V plus minus V minus equal to V. So according to Ohm's law, potential difference across the conductor is directly proportional to current flowing through the conductor. So therefore, V is equal to Ri, where R is proportionality constant and is called resistance of conductor. Because whenever there is a proportionality relation, and if after equating the two physical quantity in proportionality relation, you have to insert a constant that must be proportionality constant. And this proportionality constant here is R and is called resistance. Now we will define resistance, what we mean by resistance. So first of all, right now we are just discussing about Ohm's law. So after dealing with the Ohm's law, concept of resistance came into existence. So you have to remember. So V equal to IR. Even you can write here V equal to IR, where R is constant, resistance, and called resistance of conductor. And this can also be written as I equal to V upon R. I equal to V upon R. This implies that for given length and thickness of conductor for the given conductor R remains constant, provided temperature of the conductor kept constant. Then electric current is directly proportional to V. I proportional to V if R is kept constant. So current is represented in the previous case. I have studied about that electric current I equal to Q by T. That was the electric current in terms of amount of charge and time. And here electric current in terms of potential difference and resistance. Okay. So this is the another formula for the current. And this is the relation between current, voltage and resistance. Therefore, the current is directly proportional to potential difference provided resistance of conductor kept constant. And resistance of conductor can be kept constant by keeping temperature of conductor constant. If length and area of cross section of conductor is already constant, then keeping temperature constant, resistance remains constant. Therefore, at constant resistance, current is directly proportional to potential difference across the conductor. That is I proportional to V. Now, another aspect, keeping V constant, if you make V potential constant, then current is inversely proportional to resistance. The current is inversely proportional to resistance. More is the resistance, less will be current, provided V is kept constant. So this is the two aspects of Ohm's law. So in a circuit, if there is a high current flowing through the circuit, how can one control that high flow? By inserting high resistance through the circuit. So high resistance will control the large flow of current through the circuit. This is the resistance. So therefore, in circuit, we apply resistor. Resistor will control the flow of current through it. More is the resistance, less will be current through the circuit. Now, so far we came, while studying the Ohm's law, we came to know about the new term resistance, and which involved as a proportionality constant. Now let us check out what is resistance. So here, learn what someone asks you, what is resistance? So an electron traveling through the wires and through the loads. Load means that those devices which absorbs electrical energy from the circuit. That is called load. So an electron traveling through the wires or loads of the external circuit encounters resistance, encounters hindrances. That means while electron flowing through the circuit, through the conductor, it get opposition, hindrances, and get slowed down. And this is called resistance. Therefore, resistance can be defined as the hindrances offered to the flow of electric charge by that material or that conductor. So therefore, resistance is the inherent properties of matter. For an electron, the journey from terminal to terminal is not direct route. When electron move from one terminal of the conductor to other, one end of the conductor to other, it is not so easy. During that movement, electron has to collide with another electron, has to collide with another atom, has to collide with the walls of conductors, and therefore kinetic energy of the electron at one end is not same as it passes, as it reaches to the other end. Because during that collision, kinetic energy of the electron get lost, get decreased in terms of heat. So this is called resistance due to collision. Resistance come into existence due to collision of electron while going from one end of the conductor to another end of the conductor. So in brief, you can define resistance is the hindrances or opposition offered to the flow of electric charge by the conductor. So you can say the resistance is the inherent property of the conductor or material of the conductor, by virtue of which it offers hindrances or opposition to the flow of electric charge through it.
सर
Yes.
जैसे हम लोग करते हैं हाई रेसिस्टेंट एंड हाई मेल्टिंग पॉइंट, ये कैसे सर, हम लोग कैसे करेंगे? हाई रेसिस्टेंट होगा तो हाई मेल्टिंग पॉइंट, या हाई रेसिस्टेंट होगा तो लो मेल्टिंग पॉइंट।
अच्छा, उस पर अभी जस्ट मैंने बताया था कि रेसिस्टेंस अगर हाई होगा तो मेल्टिंग पॉइंट आपको लो करना होगा, क्योंकि मेल्टिंग पॉइंट अगर लो करते हो तो बहुत जल्दी मेल्ट कर जाएगा, क्योंकि रेसिस्टेंस हाई है तो इसलिए ज़्यादा हीट प्रोड्यूस होगा। इसलिए वो अभी अब जस्ट एनर्जी पर पढ़ाएंगे तब समझ में आएगा, अभी नहीं समझ में आएगा। So right now just you have to remember I equal to V upon R. So I is inversely proportional to resistance at constant voltage, and I is directly proportional to voltage at constant resistance. So rather try to understand, for an electron, the journey from one terminal to another terminal of the conductor, it is not direct route, rather it is a zigzag path, and that results from a countless collision with fixed atom within the conducting materials. And that's why speed of electrons, velocity of electrons get decreased, and therefore there is a loss in kinetic energy of electron, and this loss appears as heat energy, because you know well that energy is neither created nor destroyed. If one form of energy decreases, it must appear in another form of energy. So electron encounters resistance. Resistance means hindrances, opposition. So hindrances to their movement. SI unit of, now all of you have got what is resistance.
Yes,
And value of resistance vary from material to material, because atomic structure of various material are different. Therefore, it varies from material to material. SI unit of resistance is ohm. But before going deep into ohms, here we should look at here. I equal to V upon R. So R equal to what? V upon I. R equal to V upon I. So for physical formula of resistance is V upon I. R equal to V upon I. Now, in order to find out unit of resistance R, we put the unit of SI unit of V and SI unit of I. So R equal to VI, SI unit of V is volt, and SI unit of I is ampere. SI unit of current is ampere. SI unit of voltage is volt. So SI unit of resistance is volt per ampere. Volt per ampere, and this volt per ampere itself is called ohm. Ohm is because in the respect of scientist George Simon Ohm, it was given as ohm. Actually, SI unit of resistance is volt per ampere. Now, this is the resistor. You see here this picture. These are the resistor. If you go to the shop and inquire about the resistor of certain value of resistance, then shopkeeper will give you like this. And ring over this, you must see here. Ring is not a design. A ring is basically indicates numerical value of resistance. So different color of ring indicates different digit, and that's why you can measure. So this is the resistor. In actual or physical form, resistor is like this, but symbolically, resistor is denoted like this. Symbolically, resistor is denoted like this. This is symbolic representation of resistor, but actual resistor is like this, that you see in radio, TV, transistor, and many other electronic gadgets. Now, come to another point, factor affecting resistance. Hello,
सर
Ajay.
ये वीडियो YouTube पर अपलोड कर दीजिएगा ना।
अभी मैं जस्ट कर दूंगा। तो ऐसा करते हैं कि नेक्स्ट डे हम डिस्कस करेंगे कि रेसिस्टेंस किन किन फैक्टर पर डिपेंड करता है। आर यू गेटिंग? अभी जस्ट मैंने
यस सर।
जी सर।
आप बताइए, ओम्स लॉ पर हमने डिस्कस किया। सो वी